Broadcasting live from the Business Radio X mobile studio in the Valley of the Sun. It's time for Tech of the Town, your place for entrepreneurial stories and lessons from the Valley's most inspiring technology leaders.
Hello and welcome to Tech of the Town here on Business Radio X. This is the show that gets us out of the studio in Arcadia and into conference rooms of leading technology companies throughout the Valley. I'm your host, Dr. Adrian McIntyre, and we are here today broadcasting live from the ASU Research Park in Tempe inside PADT. And Eric Miller is here as my guest co-host for this episode. Eric is the co-owner and principal at PADT. Thanks for hosting us, Eric.
Thank you for coming to our, and you mentioned conference rooms, to our very beige conference room, appropriate for a technology company.
And we are joined in the studio by our featured guest here. Jan Janick is the Chief Technology Officer for Benchmark Electronics. Thanks for being here.
Thank you, Adrian.
Eric, since we're here in your house, why don't you get us a little background, a little context on PADT? You just celebrated your 25-year anniversary.
Right.
Had a great party. My kids had a good time with the bouncy castle and all that.
Yes.
But tell us about your company and how you serve folks here.
So we're like you said, we're a 25-year-old company, and what we do is we help people who make physical products make their physical products. We either sell them the tools they need by selling them the software, the hardware they need to do engineering, or we do consulting with them. And we're about 80-some people. We're located here in the Research Park in Tempe is where our headquarters is. And we've got offices all across the Southwest in California and New Mexico and Colorado and Utah and most recently in Texas.
What's the primary kind of work you do? I know there's actually several overlapping areas of expertise happening here. Unpack that a little bit for us.
There's really three areas of concentration. The first one is simulation. So we use computers to build virtual models that we do virtual testing on. That's something we do quite a bit with Benchmark Electronics, where when they come up with a new product, maybe it's got some high-frequency electromagnetics in it, and we'll help them model that behavior of that electronics, how the frequencies behave within the electronics. And then the second area is product development. It's design. It's working with people that are designing a new product to test it, to design it, to make sure it meets the qualifications of the customer. And the last is probably the one we're most known for outside of the engineering community, which is 3D printing. And so we've been doing 3D printing for 30-some years. We started the company as one of the key founding things of the company was to do 3D printing here in the Valley. And who knew it would explode as big as it is. So we do metal, we do plastic, but we do high-end 3D printing, and we sell the printers as well.
Fabulous. And of course, there's software that ties everything together, and that's got to be part of the equation.
Yeah, we sell software for each of those.
To teach people how to use the things and all that
Training and all sorts of fun stuff. And technical support, we do a lot of just phone support for people and go over and visit customers and help them be successful. And the best part of what we do here is the variety of the products we get to work on. So everything from rocket engines to new electronics to toys to aerospace components. The variety, for an engineer, it's kind of a dream job because we get to work on everything.
Now, Jan, you also have an engineering background before you found yourself as the executive of a relatively large electronics company. Give us a little bit of a background on Benchmark and then how you found yourself joining that company.
So Benchmark is a 40-year-old company, and we started as a manufacturer of medical products. I joined the company about 4 years ago after a 30-year career with IBM where I was in product development. And the reason I joined Benchmark was because Benchmark is going through a transition from a contract manufacturer to a product design, technology, and solutions provider with world-class manufacturing. So some of the things Eric talked about and the capabilities he has, we also have an offer to our customers. And we work with our customers from as early as product inception all the way through product design, verification, and launch of that product into one of our worldwide factories.
Now, you have locations all around the world, primarily clustered in Asia, in the United States, and some locations in Europe. You have a personal background that is very global in nature as well. Talk to us a little about your journey. Take us back in time to young Jan, the engineering student, and how you found yourself living and working internationally.
Okay. Well, one thing about IBM, the initials, a lot of people say IBM stands for I've been moved. And I did have a long career with IBM. I spent time in the U.S., but I also built a team in Taiwan. took an engineering team from about 30 people to about 350 people with a focus on doing notebooks and computer designs back in the PC days. In addition, I managed a team in Japan, which was the design team for the IBM ThinkPad products. One of my most interesting roles was when I was part of Lenovo. So IBM sold the PC division to Lenovo, and I spent some time with Lenovo. In that role, I ran the electronics for the Winter Olympics in Torino, Italy.
And that was mid-2000s when that sale happened, right? Or what?
Yeah, that's about right.
So I remember I grew up with IBM. In 1981, my dad brought home, what was it, the Model 5150, the first kind of consumer PC that they put out. And so I had a Commodore 64 and things, as you do when you're a kid in the late 80s, or early 80s, late 70s, early 80s. In fact, my very first computer was the VAX terminal at the college where my dad's radio station was located.
Yep.
And I remember he would go there to write papers. He had been in radio broadcasting for a couple decades, but he hadn't finished his college degree, so he was taking some classes, and he would go to type his papers at the terminal. After he was done, I said, could I play with this thing? And we've come a long way since those early days. By the time that the PC and laptop division was transferred to Lenovo, there was a lot of question about what's IBM doing now, at least from the consumer side. Maybe there was no question internally. How did you find yourself navigating that transition and then ending up on the other side with that experience? What did you learn through that process?
So interesting. I started at IBM in 1981, and I started on host-attached dumb terminals.
Yep.
And so I started at almost one of the sort of the lowest complexity hardware products that IBM delivered. And I moved from there into PCs because PCs replaced those host-attached terminals. Then I moved into notebooks. Then IBM decided to get out of that business. When I came back to IBM, I got into x86 servers and ran the server development team, including blade development. Sometime after that, IBM decided to get out of the x86 server business, and I moved on to manage a flash storage acquisition that we did. But it was an interesting transition to watch IBM move from a very hardware-centric company to a company now that is more service, software, and support.
Now, Eric, this is something that you, without being in that realm exactly, also have navigated as you moved from a very hardware-type environment. Talk us a little bit about your background.
Well, I was a consumer of all that, right? So all these transitions that you guys are talking about, I learned to program on a VAX terminal back in college, early PCs, moving towards, the servers and the blade servers and the whole transitions that you're talking about. I was on the other end as an engineer using these tools. In fact, the first computer I used was an IBM mainframe doing CAD on an IBM mainframe. So it's all changed over the time. And see if you guys agree with me on this one is what it's really enabled is us to do so much more. I mean, what we can do now on a laptop compared to what I did on a FPS or an IBM mainframe or a Cyber 25, 30 years ago is insane. And it's the value and the productivity that we have now is a little bit mind-numbing sometimes when we think back on it. But very good. I mean, think of the products you guys are developing for your customers, how much you use computer-aided engineering to do that. That's all that technology you developed over those previous years.
Right, absolutely.
Yeah.
Now, Jan, there's a wide variety of industries and perhaps innumerable number of products that Benchmark is involved with. Can you characterize at some level of abstraction the different types of products that you provide and help people really understand the scope of what Benchmark is providing these days?
Okay. We are focused on a number of verticals. Probably the first one I'd like to talk about is medical. We do a large number of medical products. We will do medical products up to the point where that medical product would be implanted in a person. We do not do implantables, but we do pretty much every other sort of medical product. That is our heritage. We understand the FDA certification process very well. We understand how to manufacture and help our customers get through that process. So medical is big for us.
Now, just to take a little slight historical detour here, there was a moment in the company's history when it was just called Electronics, Inc. Is that correct? I think I read that in the history of the company. That seems like a pretty awesome name. Just Electronics Incorporated.
Right. Very much so, right? Very broad. And we are actually Benchmark Electronics, but we are starting to drop the electronics piece because we do a lot more than electrical design. In medical, for example, we do microfluidics for cartridges, for doing tests for patients. We do pumps for dialysis or for providing a medicine to patients. So we are much broader than an electronics design house.
It's interesting now. You're touching on something really important. Let's pause here for a second. It's not only that electronic circuits have gotten smaller. The applications themselves have gone micro and nano. So you're talking about the smallerization of things at a level that I think those of us on the consumer products side probably aren't aware of the significance of this. I was marveling before we turned the microphones on at how small the micro SD card that we record a backup copy of our shows on is, and that you can get 256 gigabytes of memory on this thing. That in and of itself is not the kind of miraculous sorts of amazing small things that you're working with. Can you give us some insight into some of those applications or some of those unique dynamics?
So as an example, we provide a piece of medical equipment to a doctor that allows them to insert through an artery in your leg an electronic circuit that ends up in your brain and it performs a function in the brain. Just think of the miniaturization required to provide that kind of electrical capability and function into an individual's brain.
You look at the cardiac assist devices as well. I don't know if you guys work on those, but it's so small, and it's if you're starting to get a heart attack, it shocks your heart. So it monitors it, and it's totally embedded inside the body. So it's just amazing how small it is these days.
As an anthropologist, that's my background and my intellectual inclination. I tend to look at things from this human-centric point of view. And the point in our history when our technology was the same size or larger than us is long since past. But the idea that we now have active, manufactured, non-human technologies injected into brains is fascinating to me because it does raise some profound questions, not relevant to this show necessarily, about where we will ultimately be drawing the line and whether some of those cyborg fantasies of the 70s and 80s kind of science fiction might be playing out here. Eric, you see some interesting developments as well through the lens of the design, the manufacturing, the printing of things. What is interesting and compelling to you these days as you look out into the general landscape of technology, electronics, manufacturing, and so on? What are some of the biggest trends?
Smarter. The big trend is smart devices. So something that we maybe have had for many, many years, we're now putting sensors on it. We're now connected to the internet. So the term we like to use is Internet of Things, right? So it's ability to take any device, put a sensor on it, put it where you need it to measure things, get the data, use advanced algorithms to look at the data and make decisions from it. And that's across industries. Everything from, everybody knows the Nest thermostat. That was kind of the big one that everybody knew about. But on the industrial side, every bit of machinery that we're designing now is smart. They are all connected. They all have the ability to do things beyond their basic capability. And that's the big trend. And miniaturization has really helped with that. More efficient power, I think, is probably the bigger breakthrough so that we don't have to have a giant battery that goes along with everything. So there's just a lot of things coming together to allow smart devices to happen. And back to your thought about, miniaturization and these things, one of the things that's happened is, we could look at a steam engine and see what a steam engine is, right? And when you're talking about things bigger than us, we're getting to the point where it's literally a black box that we can't even see now. So we don't really know what goes on inside that thing. And I think that's the social implication that we have to really think about is we treat this as just kind of accepted as magic and there's a few of us that kind of understand what's going on under the hood, but most people don't. And it impacts their lives. So I think educating people to understand what this technology is and how it impacts them socially is something we need to go really focus on. And privacy on the internet, of course, is the most obvious thing, but all these technologies we're talking about.
Now, as young men studying engineering in the 70s and 80s at top schools in this country, were you even aware at the time the direction this was all going? I mean, it'd be nice to pat yourself on the back and say, yes, of course, but certainly there was a sense that things were happening. It was even then an exciting time. Everything was changing. Talk a little bit about how your perspective, Jan, has shifted over the years as you have participated in some of the companies that have led these changes. How has it changed the way you think about engineering, but also about life?
When I started, we provided sort of the technology that engineers or companies like Eric's would use to create products. And what happened and what I've seen really be a shift is those tools all exist now, and those capabilities exist. And engineering today is really much more about using the capabilities and the tools that exist to very rapidly create products. So I've seen this shift from being the provider of the tools to being a user of those tools in an engineering level to create the new products.
So there's libraries, if you will. It may not be the right language, but
literally, modules and libraries.
And libraries.
Building blocks.
You can take things off the shelf, whether it's in machine learning applications or others. You don't have to invent the basic framework. You have to then figure out what you're going to do with the frameworks to solve problems.
A great example is artificial intelligence, right? So back in our day when we were playing with artificial intelligence, you had to write your own code and in bizarre languages like Lisp. Now you can go and download a module, and anybody can do machine learning. Anybody can do artificial intelligence by just applying that. The experts have created these tools, and it's a really good point across all of engineering. A lot of what we're doing is integrating tools and making better products, which is what we always are doing. But we don't have to get down into the weeds to write our own code or create our own hardware. A lot of it's modular now, right? In the electronics world, everything's systems on a chip now. Right, and that used to be a box, and then it was a board, and now it's just a chip.
Jan, I'm curious about your evolution from engineer to executive, because the human systems, the human operating systems and hardware, if you will, wetware, or whatever you want to call it, have not evolved all that much as workflows have changed significantly, as the speed of development has changed, as the way teams have worked together has changed. Tell me some of your observations about leading people inside of these kind of organizations.
Excellent question, because I went to school, University of Wisconsin-Madison. I got my master's degree in electrical engineering. I was going to be a 30-year engineer in my career. Actually, less than 5 years into my career, I realized that the impact I could have as a single engineer or an engineer on our team was small compared to the impact I could have leading an engineering team. And I never thought I would get there, but it didn't take me long to want to make the shift from hardcore engineer to technical knowledge and leading an engineering team. It is actually pretty simple to lead an engineering team. Give them a vision, give them an interesting, challenging set of engineering work, and give them the tools they need, and they will go do incredible things.
Clear goals, the right tools. It's amazing what engineers can do. Yep.
So take us to that period, 5 years into your career, post-degree. What was it that had you start to realize that in addition to your engineering abilities, that you had this desire or this skill set and it was something you wanted to pursue further? Do you remember a moment or a period when that really became obvious to you?
I don't. And as an engineer, I think I was more the typical nerdy engineer, the guy who likes to take things apart, put them back together, not sit down with an individual and tell them to go spend time on this or focus on this. But I don't think it was a moment. I think it was a transition from I can have this impact on this part of this product, or I can have an impact on this product line, or I can have an impact on the direction of this technology. And it's sort of every time you get a piece of an ability to influence more, you want that next piece.
Mm-hmm. Yeah, I think it's really key to the other thing in the picture for me was being around examples of good managers, right? So, maybe IBM had it, but we didn't have any kind of training, right? You just kind of learned on the job with a lot of this stuff. And so having I don't know if mentor is the right term, but good examples that you could look at and say, wow, this person knows how to run a project, or this person knows how to lead a team, and trying to emulate that and going to them for advice when you can. I think is key in making that transition from an engineer. If you're an engineering engineer, it's just not natural generally. And so having other people that have made that transition around you, and I was lucky enough to work here at the company that's now Honeywell, but it was Garrett when I worked there, where we just had these guys that were naturals at it, but they were fundamentally started as engineers. So watching them do things is how I learned.
Now, Eric, after over a decade in the aerospace industry, you and some friends decided we want to start something.
Right.
We want to leave and create our thing.
Mm-hmm.
In an interesting way, that's also a major inflection point.
It was major, yes.
Take us into that period. So this is early mid-90s?
93 is when we decided to do it. 94 is when we launched the company. It was a transition period in aerospace, both technically and business-wise. A lot of work was starting to go offshore. But technology was coming along. Computer-aided engineering was really taking over as a common tool rather than just kind of a niche tool. So we were using this high-tech stuff as a kind of internal consulting company for the rest of the company. And then as computers became better and cheaper, we kind of, for once in our lives, guessed right about a trend that this would be a tool that all engineers would use. So simulation, 3D printing, advanced computer-aided design. So that's we kind of sat there and looked at it. And in some ways, as an entrepreneur, ignorance was bliss. We didn't really know what it would take to build a company. So we didn't have a lot of fear. We just thought we would set up a shingle and customers would come. Well, that doesn't happen. But the nice thing is we did adapt and learned how to attract customers and how to grow the business.
What was your initial move? You had been an internal consulting team. Mm-hmm. Did you decide that that's what you wanted to do outside?
Yeah, basically apply that technology outside of turbo machinery was the idea. It was this stuff that we were successful with jet engines could be applied to any industry.
And did you lead with consulting, or did you lead with design, or were you that mix from the beginning?
We led with 3D printing and simulation.
So much has changed in the entrepreneuring side
completely
of technology. Silicon Valley now has a certain mystique and lore to it, and what 20-something entrepreneurs think they understand or do in fact understand about the current state of things is not the way it was in the good or bad old days, depending on your point of view, in the 80s and 90s. What does present day Eric know about running a company that would be applicable to someone even in today's very different landscape than when you started?
It's not about the technology. It's not about you got to have a good technology. You're building your company around a technology. That's really important. You have to have that or you're not going to be successful. But to be successful, the differentiator is you got to learn how to run a company. You need to learn how to do sales. You need to learn how to do marketing. So it's the full spectrum. That's what I would say to startups now is the technology is fundamental. You have to have it. But that's not the difference between the successful companies and the unsuccessful companies. It's the people that have technology and know how to build a company, scale, do marketing, do sales. If you build it, they will not come. That's the biggest lesson I've learned. You got to get out there and pull people kicking and screaming as customers. And you guys are probably going through that now as you make your transition.
We work with a lot of startups. Mm-hmm. They have good ideas. They don't know how to productize.
Right.
They know technology. They know how to take a design to a certain point. But turning that into a product that's manufacturable and sustainable, that's a challenge. And the other piece is you go to a lot of these companies with really cool technology and you say, how are you going to get that to market?
Right.
And you get a blank stare. So you're right. We see it with the startups we work with.
What have you learned, Jan, that as you advise and interact with startups in that situation, what are some of your tried and true lessons? What do you find yourself sharing over and over? In other words, what's something that might be missing in the general conception that an experienced executive with deep technology background can share? In other words, what do the old guys know that the kids don't? I guess is kind of what I'm asking here, but respectfully.
I would say focus would be one of the biggest things. As we talked about with the tools, it's easier to create new products than it has been, and a lot of startups want to do their third product before they're successful with their first. So focus, get the first one right, learn all of the hard marketing, sales, production challenges with that before you try to do, phase 2 or product 2, product 3, product 4.
So depth before width.
Yes.
And minimum viable product. We use different terms in different industries, but the idea of making that product that just got enough features to be successful. Because I think what you probably see this a lot is they come in with a feature list a mile long, and they only need 3 of them to be successful in the market, and then they spend all their money on the other ones. So setting priorities, focusing, I couldn't agree more, and it's just staying on message and staying on process. Even if it's other people's money you're spending, treat it like yours. That's another bit of advice I would give the younger startups. I think sometimes they go a little crazy because it's not really their money. But the companies that we see that have the discipline of treating it like their own money tend to be more successful, and they go on less of these dead ends that we see. The biggest thing that's changed from our days early on is large corporations funded R&D back then. The model now is you go out there, come up with an idea, whether it's from a university or yourself, go raise money, prove it in the market. Then the large company will fund you maybe to get the next step, or they'll just buy you. I'm not. We'll know in 30 years whether that's a better model or a worse model, but it is the model now.
It is the model,
yeah.
Definitely.
And so you need to accept that fact, and that the failure that used to happen inside the walls of a lab. I mean, think about when you worked at IBM, how many projects never went anywhere, right? Now that's happening out there in the marketplace. So that's probably the biggest shift that I've seen besides the technology is the whole way things are done and funded is totally different. And hardware is hard. Software, you can get to market a lot faster with hardware, but hardware takes time and money and manufacturing expertise. So it is a little bit different, but it can be more fun too.
A couple of years ago, Benchmark relocated its headquarters here to Arizona. Why?
A couple of reasons. One was our headquarters was 30 miles south of Houston. It was not a headquarters that was either location-wise or style-wise or innovation-wise a place we wanted to bring our customers. And as we were making this transformation from a contract manufacturer to a product design innovation company, we decided we needed to move that factory. We needed to move headquarters. The second piece was because of where it was located, we did not have the entire leadership team present at that location at all times. And so we got a new CEO. He made the decision we're going to move. We're going to move to a place that is a vibrant technical community. And we're going to build a headquarters that we are proud of bringing customers to.
At the time, there must have been many candidates, or at least more than one. There are a number of emerging tech hubs that are not in California, where costs of doing business and costs of living are higher. I'm a California native. I say that with no negativity, but it's just true. What were some of the factors that played out and had this be the location? Was it just that the number of days of sunshine plus that commercial real estate is affordable? Or like maybe you weren't involved at the time, but I'm curious to know from your perspective, why Phoenix?
So one, I was very involved in the process, which was a lot of fun. But why Phoenix? As you said, California was too expensive, but we wanted to be proximity to the West Coast, ability to work with those West Coast companies in a 2-hour flight or less. That was important. Access to a university with a very good engineering program, both for access to the expertise of the professors and the staff, but as well, we are doing significant hiring to the engineering skills that they are graduating. Sunshine wasn't actually part of the corporate decision process.
It rarely is. I wish from an economic development standpoint, I wish we could use it more often. But Houston, You were in Houston, so going down to Austin was probably on the table. And I always like to contrast us with Austin. Was that part of your process? And
we did look at Texas. We looked at both Austin and the Dallas area. I can't tell you exactly what it was that pushed us over the edge, but we did look hard. We looked hard at Colorado. We looked hard at Texas. We looked a little bit at North Carolina, and we ended up here.
That's good. Well, we appreciate you choosing here, and your location's beautiful. It is definitely a showcase facility there up by the river, right?
Thank you.
Yeah,
yes,
that's just beautiful.
You've lived in a lot of different places where innovation, technology have a life outside of any one company, where there's a culture, if you will, a shared environment, an ecosystem. What's your take over the last couple of years on where we are here? What are we doing well? What are some areas of opportunity? And what's your sense of the future for technology in the Valley?
So, again, I've been moved to IBM. I lived in a lot of different locations. And interestingly enough, college town state capitals are my favorite. They are vibrant. They have skills. And it's interesting that we picked Phoenix that also has that same characteristic.
Yeah.
Yeah.
I mean, I lived in Austin for 2 years in the late 90s, and it has that interesting mix of large tech, of state government, of a very large public university, and plenty of wacky street culture to go with it.
We're working on that here. We're working on the street culture here.
Yes, the murals are on point here.
The murals are kind of on point, and musicians they're not there all year, but when the weather's good, they're out on the street corners. So
when you and your co-founders decided to break away and start your own thing, was there ever a question of moving somewhere else, or did you stay here because you were already here?
Well, our full name is Phoenix Analysis and Design Technology, so we pretty much committed to the Phoenix area right in the name. So, yeah, it always made sense because we felt that it was a competitive advantage even back then because of the cost advantages compared to California, and yeah, that was the key thing is we knew everybody here, we had relationships here, and growing here is just easier. That's one of the biggest things we've found, and I think it's still true. It's never easy to grow, but Arizona doesn't necessarily get in the way as much as some other places.
What are some of the key points of focus for each of you as you navigate through your day? You're working on a wide variety of things. You're managing very multifaceted organizations. What are some of the topics that consistently are on your mind as you're going through this process in your own company?
Let me do tactical and strategic. Tactical is at any given time, my engineering team is probably working on 100 different projects for customers. So tactically, it's where is that project? What are the challenges? Are we getting past those challenges? Strategically, it's much more as we look forward, what technical capabilities, what technology, what expertise are my customers going to need in the future, and how do I build those skills in my engineering team so when those customers come and ask me for that, I have that level of expertise to provide to them.
So before I answer, I've got a question based upon what you just said. One of the things I don't have to deal with is 100 projects. I got to deal with 10, right? So I can keep my fingers in each of those. What's your advice or suggestion for people that are looking at a large organization, and how do you, at the top of that pyramid, make sure everything's moving in the right direction from a tactical standpoint when you've got so many little moving pieces?
That's pretty simple. You got to have a good team.
Okay.
And that team's got to follow a good set of processes, and you really just have to manage the exceptions. Okay.
That's a really good point. That right there is a book. So there, well, I get to write the back if you write it, the back cover. So for us, I think the key thing is, again, you got to separate into tactical and strategic. And the biggest challenge that we face is making sure, because we're small, that you're focused on the things where you're adding value, rather than focused on the things that you want to focus on. Personally, that's one of my issues. It's like I want to work on stuff that I want to work on, and there's probably stuff I should be working on that has where I add the most value to the company. And that's when you're in a smaller company where you can get your fingers in every pie, that's probably the biggest challenge.
Keeping them out of pies that you don't necessarily need to be in just because those pies are interesting.
Those pies are interesting, and there's one pie that I should be doing because I add the most value to that pie, whereas the other ones may taste better, and that's the reality of it. To take the pie analogy way beyond where it should go.
So it's the engineering you wanting to stay on the technical, fun engineering stuff,
or even the non-technical with the marketing side of things. I want to play with the page layout. Should I really be spending my time playing with the page? I should probably have somebody else do that.
There's something in that jack of all trades, which is enjoyable and challenging. I can certainly relate on a much smaller scale in our operation. Where at the moment I am the one doing everything.
You don't have a choice.
We're early on in this. The network has been around 12 years, but my little piece of the network has been around 5 months. What are some of the things that have surprised you, Jan, about Arizona? It was attractive. You obviously led the decision in a way to be here, but now what have you found and come to love? I'm not trying to puff up Arizona. I'm really trying to get under the surface of things because at some level the conversations about this are not all that interesting. They're sort of generic, but I think from the trenches, you probably have a unique perspective. What are you liking that you found here that maybe you didn't realize was going to be the case?
I think what we're liking the most is that it wasn't just a sales pitch. The university didn't just say, we'll work with you, and then when we moved here, they backed away. The technical community didn't welcome us and then say, well, we really don't have a technical community here. So I think the thing that we found is that everything we were told and that helped sell us on this is turning out to be pretty true.
That's good to hear. I mean, I think that's one of the things that I always mention that differentiates Arizona is we're very get down to basics and get work done, and so there isn't as much hype. But I think it's a really good question because, we're not trying to puff up the state. We are in transition. You're one of the few companies that's headquartered here in the state, right? We would love, from an economic development standpoint, to have more. And so what would you say we could do as a tech community to attract more headquarters here to the state?
Boy, that's a tough question because you did attract Benchmark. But again, the access to skills, very important. The technical community, the fact that you're part of a bigger community and the community works towards the good of the technical community. Those are all very positive. We at Benchmark, honestly, when we had our headquarters 30 miles south of Houston, we did not participate in the community because there was no community.
Well, you weren't oil and gas.
Right.
If you're not oil and gas in Houston, there's not much going on.
Here, much of the leadership team has reached out and is participating in the broader technical community.
And let's talk about that community for a second because I think there is uniqueness to it. So different organizations, obviously Greater Phoenix Economic Council on the economic development side, the Arizona Technology Council, which brings a lot of the tech leadership together, the Yes PHX #/ecosystem/community that brings in a lot of not just founders, but also other vendors and service professionals that want to work with startups and want to participate in some way. And then, of course, ASU itself. What are some of the key elements of this community that, you've recently joined the board, Janet, the Arizona Technology Council.
Yes.
What are some of the other interesting bright lights in your point of view?
Let me give you one example because I'm also on the board with Kyle Squires, the dean of the engineering school at ASU. And we have discussions that go something like this. What do you need out of the engineers that we're going to graduate next year and 5 years from now? What capabilities do they need? What are the things that you want? And the fact that the university is asking us that, and we get to help participate in helping them design how they train and educate engineers for the future, that's a really good example, I think, of where the involvement of the technical community will pay dividends in the future.
And I'll point out another organization that wasn't on that list is Arizona Commerce Authority. So it's a unique semi-governmental. Somebody that's an expert will have to explain exactly what it is. But it's not a department in the government and it's not a private company, but it's somewhere in between. And they do a great job of bridging things. And I'm sure they were involved with you guys getting up and going and everything. And they've been a great resource for the startup community as well as the established community. I think the fact that So at some point in the past, we decided we're just not going to be a place where companies locate their other office, and we're going to actually try to work together to create a community. It's kind of funny because we all decided to kind of do that years ago, and then we woke up one morning and it happened. And I wish I could point to the point where it did, but it's good to hear that when you came here, you found it, and it's really important. I was involved in a discussion of a large group of executives that are part of the Tech Council about the Tech Council. And what I was amazed is in this room are some of the leaders in technology companies in the Southwest, and they gave up an entire afternoon to sit down and give back to the community. And the ideas were great. The interaction was great. Everybody was working together. I think this is... It's a great opportunity for us to really get to the next level, and it's all about creating a place where people want to work and live and make a good living, and that's I think what we're all focused on, and it's good to see that we're making progress.
Jen, what you mentioned a moment ago about the deepening of relationships between industry leaders and universities, particularly in STEM, but in other areas as well, is a trend that's increasing nationally as universities have, to a certain extent, struggled to manage the kind of workforce development that's being asked of them as they're questioning at some level the future of the entire model itself. Some more are questioning this more than others. The idea of reaching into the curriculum and into the practical training, not just offering internships, but actually getting involved, bridging at a much earlier stage than a career fair.
Yeah.
The relationship between companies and campuses is a trend. What are you seeing are opportunities to deepen that relationship in the future? And universities, and the enlightened ones anyway, or enlightened deans within universities wanting to build those kind of bridges must be interested in your feedback as well. Tell us the truth. What are you not getting from us that you need to provide? And what's the answer to that?
Yeah, and the interesting discussion is we don't talk about the fact that you need to teach more wave theory or you have to be stronger on digital or semiconductor. We talk about how engineers are going to work in the future. They are going to work cross geography. Teams are not going to be physically located together. How do you train your students who are all sitting in the same classroom to work as a collaborative team across multiple sites, multiple cultures, and design and develop products at a very rapid pace? So it's less about the technical side of things and more about sort of the technical community's vision of how engineers are going to work in the future, how products are going to be developed in the future.
That's a very, very good point. The idea of being able to work with cross-geography, cross-cultural teams in very tight time frames it's a nature of the way the world is working increasingly, and it's not a skill set that the professoriate is familiar with. So, and the idea, although you have less of this in science, technology, engineering, and so on, but the idea of the lone scholar hero that dominates the humanities and social sciences, which is more where I come from, you get less of that in your part of campus.
There's too many of us to fit in the ivory tower. That's the problem.
Right. Well, but there always has been.
Yeah, always has been. Yeah.
I mean, since 1965, which was essentially the peak of hiring for college professors in this country, post-World War II, boom, GI Bill created a flood of graduates with higher degrees as well as opportunities for them to teach. And every year since 1965 has been in decline. So there's a reason why this PhD works outside of the university, and it's something like only 10 or 12% of any field's graduates with their top degree, whether it's a PhD or a master's degree, whatever their field is, end up back on the faculty. So you have people whose primary career path is university-based teaching, who of course are involved in other things, right, keeping current and active in research and publication and industry relationships and so on. But really so much of the innovation is being driven outside in terms of the way people are working now. Right.
And let me give you an example. The millennial generation, or the younger people, don't talk as much. They text. Right. They communicate in different ways. Boy, if you can design a complex medical product by texting in the future, I will be amazed. But the social norm for communications that some of the younger generations are living in does not support the collaborative requirements of designing products in the future.
Collaboration in general is one of those core skills that's not taught in school, along with balancing checkbooks and things of an archaic era. What's a checkbook? Venmo me. And,
exactly right.
But no, I really do believe that there's some very fundamental skill sets in communication, storytelling, interpersonal communication, as well as the way of working together as a team that are not being taught because the teaching environment was never done that way. So we're almost retraining the teachers. You see this in undergraduate education with the rise over the past 10 years of project-based learning. And the biggest issue with that was that every single college professor had to figure out how to do that because they were never taught to work together with anybody. It was, I go to the library and do my thing, or go to the lab and do my thing. Eric, what are you seeing with this?
I think it's a really good point, because universities are siloed. And we talk about cross-cultural. I think a bigger issue in cross-cultural and engineering is between the mechanical engineer and the electrical engineer, there's more of a language barrier than between, say, the Chinese engineer and the American engineer, right? We speak a different language. We look at problems differently. We solve problems differently. And so when you have a university that's very siloed, where the electrical engineers and the mechanical engineers don't work together, it's been a problem. And a big trend right now that I think is paying off, and you may be seeing it as well, is multidisciplinary studies. So when these people graduate in their expertise, they have worked on projects with other majors. And that's been a really positive trend and needs to be done more, because like we talked about earlier, the tools are great. It's really about getting to the answer faster and better. And a lot of that doesn't have anything to do with the, calculus. It has to do with how to work together and how to collaborate and how to create objectives. It's all process. We haven't talked a lot about process, but because most people listening aren't engineers, but where we live and breathe on a daily basis is about creating and following processes. That's the key to good engineering. And I don't know if they even teach that.
And the point you made earlier about taking a design to a good enough point, how do you know what good enough is?
Exactly.
Where do you learn that? That is not something that is being taught today in the universities.
And the feedback loops with team leaders and customers that you would have in industry are also not present in the learning environment of many universities. You might have some peer feedback. You might have your professor or lab leader's feedback, but it's not the same. Customer feedback is a whole other animal altogether.
It'll be interesting to see, because that's such a huge part of agile development on the software side, right? That whole loop of back and, dealing with small chunks and getting feedback throughout the process. So I'm curious to see if it's going to spawn on the university campus from the computer science side, because it's so fundamental to the way you write code today. So it'll be interesting to see if they create that germ that spreads to, there is no feedback loop other than what EBIT, which is the organization that decides whether you're accredited or not as a university. They listen to industry, and they put some requirements for universities to follow, but it's kind of polling rather than it's literally grabbing by the hair and dragging them forward. So I'm hoping to see more changes as more leaders get involved, like Benchmark has with ASU. I mean, it's a two-way street, right? We've seen it, their involvement at ASU, watching from the outside. So it's not just ASU reaching out to them; it's the company reaching back, and that two-way is fantastic.
But by way of wrapping up our conversation, Jen, what's something that you're excited by as you look into the future? What's on the horizon that is lighting you up and contributing to you getting out of bed and jumping back into the trenches every day?
Technology continues at an incredible pace. And as technology continues, so does the ideas and capabilities that engineers have to turn that into products. It is amazing every day to watch new customer engagements with the new product challenges they have and the new capabilities they bring in. And within Benchmark, in my IBM history, I was very computer-centric. But in Benchmark, we do aerospace and defense, we do medical, we do industrial. I get to work on I don't get to work on. My engineers get to work on a very broad set of products. And it's just exciting to see the continued innovation supporting the continued technology, rapid changes that are going on in the industry.
Eric?
Yeah, I'd echo that. It's a change is just amazing. And, it's really about, for me, what I'm excited about is, there's disruption that you can do from a consumer standpoint that creates new markets. But in the long run, what I'm more excited about is how it's going to increase quality of life for everybody on the planet, right? So, let's just take water as an example, right? The ability to get clean water for people in most of the world, that's a technology problem. And it's a technology problem that we're starting to solve. And to me, that's the kind of thing that's super exciting. And yeah, the flex circuits that we developed so you can fit more crap into your cell phone, that's awesome. And it sells more cell phones and better selfies, right? But it also is going to go over into better water treatment systems, or maybe better satellites that'll create better communication networks and give people more access to information and learning. So, where these things end up is the fascinating part to me, and the thing that I get most excited about.
So build a better selfie and the world will beat a path to your door.
That's right. You don't have to go to the moon, right? We always justified spending all that money to go to the moon in order to create Velcro, right? But maybe it's selfies now.
Well, there is definitely an interplay between the consumer demand for things and the way that this all plays out. And in a fascinating way that we don't spend a lot of time dwelling on because we're not philosophers of science and technology, it really does change at some fundamental level the prospects for humanity on this planet. Well, it's kind of a lofty way to end this conversation.
Yeah, we'll start on a high point. Let's finish on a high point.
I like it very much. I just want to thank Eric Miller from Phoenix Analysis and Design Technologies, better known as PADT, for hosting us here today, and Jan Janick, Chief Technology Officer at Benchmark Electronics. Thank you both for this conversation.
Thank you.
Thank you very much. It was fun.
And for all of us here at Business Radio X, this is Dr. Adrian McIntyre, and we'll see you next time on Tech of the Town.